Hey, this is Satish. Welcome to my channel. Today we are going to solve the circuit and understand what the 6 ohm resistance sees in terms of the Thevenin voltage and Thevenin resistance across terminals A and B. So let's get started. So we have this circuit. So we have three different voltage sources. So to understand the effect of each one of them independently, so we can short out two of them at a time and understand what is the effect of each of the voltage sources. So if we start, so let's short out the first voltage source, and then we have the terminals A and B. So let's remove the load resistance, the 6 ohm resistance as well, and then we have the 8 ohm resistance, and we have a short across this as well. So basically, so what is the voltage at B, right? So let's just call it B VB1, and that voltage is basically 0 volts, and this 8 ohm resistance goes out of the picture because we have a short across here. And what is the voltage? A1. So to calculate that, this is basically a voltage division between the 4, 8 and 2 ohms. So VA1 would be 2 divided by 14, which is this voltage VA1 times 40. So I'm just doing basic voltage division. So this is 40 by 7 volts. So that's VA1. So what is VA1 minus VB1 in the first circuit? That is 40 by 7 volts. So this is our first voltage with the first voltage source. Now let's repeat this exercise with the second one. So basically we just short out the first voltage source, have an 8 ohm resistance to 10 volts ground, so again, what is VB2 here? Again, it's directly connected to ground, and this goes out of picture. So this is 0 volts. So it is VA2. VA2 is again basically voltage division for the 10 volt voltage source. So you have 12 divided by 14 times 10, 60 by 7 volts. So VA2 minus VB2 is 60 by 7 volts. Now let's do the final voltage source. So we have a short. So from this we can see that VA3, right, so here it's not directly connected to the voltage source. There is a open here, and then it's connected directly to the ground with the 8-2 and the 4 ohm resistance. So basically the voltage A3 would be 0 volts. So VB3 is going to be, so you can see that B is directly connected to the 20 volt voltage source, so that becomes 20 volts. So with this, VA3 minus VB3 would be minus 20 volts. So VThevenin across terminals A and B is going to be, so we just have an algebraic sum of these voltages. So it's just 40 by 7 so that's our answer. This comes out to be minus 5.71 volts. And what is the Thevenin resistance that's looking into the terminals A and B? So to calculate that, we basically short all the voltage sources. So it becomes basically this becomes 12 ohms, 8 and 4 in parallel with 2. So you get across A and B, you have 12, 2, A and B, and then this 8 ohms goes out of picture. So you have this. So RAB, or this is R Thevenin, becomes 12 in parallel with 2, say 12 by 7 ohms. So basically this whole circuit across the 6 ohm resistance becomes a voltage source minus 7, then you have 12 by 7 ohms, then you have cross terminals A and B. Thank you.